In problem 11, we're given log 2, the value of log 2, and the value of log 3. But we're asked to determine what's the value, the approximate value of log 18. So we need to use what's given, log 2 and log 3, and change log 18 so that we can express it in terms of log 2 and log 3. So let's first break log 18 down into only 2's and 3's. So we know 18 is equal to 9 times 2, which we can rewrite as 3 times 3 times 2, since we only have these two options to work with. Before we plug in our values, we need to actually write this so that it's in terms of only log 3's and log 2's. Right now, we have log 3 times 3 times 2. But using the product property of logs, we can expand this and add log 3 plus log 3 plus log 2. Now we're ready to plug in the values that we're given. So log 3, and we have 2 of them, so we can write that as 2 times 0.4771, plus log 2, which is 0.301. So looking at our options here, option A matches our answer. In problem 12, we need to choose which of these systems of inequalities matches the graph that's provided to us. So let's start with the horizontal line. The equation of the horizontal line is x, it would be y, and we know that it's going through -4. And looking at our shading, this is being shaded above or greater than y equal to -4. So we know this will be one of our inequalities. So we can immediately cancel out option B and option D. So we need to choose between A and C. So let's look at our second graph. We know the equation is -3x plus 1, so we don't need to determine that, but we do need to determine whether it's being shaded above or below. The shading here is above the line, not below the line. So above means greater than, so y is greater than -3x plus 1. So our answer is C. In problem 13, we need to find the x-intercept of the graph. When you're crossing the x-axis on any graph, your y value is always equal to 0. So if we're finding the x-intercept, we can set y equal to 0 and solve for x. So 8x minus 3 times 0 equals 9. This gives us 8x equals 9, or x equals 9 over 8. So the x-intercept as a point would be 9 over 8, 0. In problem 14, the function is given and we're asked to evaluate the function for an x value of -4. So if x is equal to -4, let's evaluate the function. F of -4 is -3 times -4 plus 5, which gives us positive 12 plus 5, which is 17. Answer D. Problem 15 gives us a composition of functions. G of x is being plugged into the function f. So if we take the function g and we plug it into function f, we're essentially placing the x plus 2 in place of this x. So let's rewrite function f, but plug g of x in place of the x. So f of g of x equals 2 times the quantity x plus 2 squared. So I replace the x squared with quantity x plus 2 squared, and then plus the 6. Common mistake here to make sure you avoid is to not, so this is not equal to 2 times x squared plus 4. You cannot distribute an exponent, so this is not equal to x squared plus 4. So I'm going to cross this out and show that this is not correct. let's do this the correct way. X plus 2 quantity squared is x plus 2 times x plus 2. So evaluating this, we get 2 times x squared plus 2x plus 2x plus 4, or x squared plus 4x plus 4 plus 6. We can now distribute the 2, which gives us 2x squared plus 8x plus 8. And don't forget that 6, combining like terms, gives us 2x squared plus 8x plus 14.